Guys, today's notes are on 4.9 and we're going to be talking about modeling with polynomial functions. What modeling is really just writing an equation. And so we're going to write polynomial functions for a set of points. So far we have used x-intercepts of polynomial functions to write equations in factored form. But to get an exact equation, you need to calculate and solve for a, which is your vertical stretch or shrink. A few of you guys have asked how to find a in one of our tasks already, but we haven't really explicitly learned how to find a yet. This is going to be very similar to how we found a in chapter 2 when we were finding the a value of our quadratics. And in order to do this, you need to be given additional information, and you need one more point. So let's take a look at our example. We know that we are given that this is a cubic function, and we're given a graph, which means we have x-intercepts, and we know that y equals, if I don't know my vertical stretch or shrink, but I do know that I have two x-intercepts. So my first one is at -1, that means x plus 1. And then I do know that my second one is at 1, 0, which is x minus 1. And at this point, there is a multiplicity of 2 because there's a parabola at x equals 1. Once we have this, you need to have an additional point. Okay, you have to be given an additional point that you can plug in, and once you plug in your x and y value, you can solve for a. So now I'm going to plug in x, y, solve for a. So my y value is 3. I don't know a, and the biggest mistake that people make is they just ignore it completely. You still have to plug it in. So x is 2 plus 1. The other x is also 2 minus 1 squared. Okay, so this is just like chapter 2 where we only had like one parentheses. Okay, so now let's solve and simplify. We're going to combine these two together, right? So we have a times 3, and then 2 minus 1 is 1 squared equal to 3. These are all multiplied together. So this is a times 3 times 1, and that is 3a equals 3, and all that work for a to equal to 1. Now it does say to write a cubic function, so you cannot box a here and tell me that you are done. You have to write y equals 1 parentheses x plus 1 and x minus 1 squared. Okay. You don't technically have to write the 1, but the 1 shows that I thought about it, I found it. You can also write just y equals x plus 1, x minus 1 squared. Okay. If you give me the bottom equation without doing any of this work, I know that you just got lucky. Okay. So here's a you try. Please take a moment and see what you can do. Right? So you have 3 x-intercepts this time and a y-intercept. Now a y-intercept can still be your x and y. The point that you are using to find your stretch or shrink just cannot be on the x-axis. Because if you are given another x-intercept and you plug that in as your x and y, then how do you know that it actually goes through the correct stretch or shrink as you go away from the x-axis? Okay, so pause the video here and I'll show you my answer in just a second. Okay, here's your answer for you try 1. I solve for a after plugging in 0 and -4 for x and y. Be careful not to switch these. The mistakes that I see students make is that they sometimes put 0 for y and x is -4. You can also do a logic check. If I am going down on the right, I know that my leading coefficient has to be negative, so just make sure that your negative shows up here. Okay, for the next one, this one is a little bit trickier in the sense that I am not telling you which ones are x-intercepts clearly on a graph, but I think you can see that this is an x-intercept, this is a y-intercept, this is an x, and this is an x, right? So this right here, this is your x and y that you're going to plug in. This is just an x-intercept. and x-intercept. Okay, give it a try, see what you get. Here's your answer. Let me know if you think there's any mistakes. I'm pretty sure these are right. Okay, let's move on. Another thing we've learned in the past is finite differences. Remember that I used to give you a table and you had to tell me if it was linear, quadratic, or neither. If you don't remember, here's your quick review. You had to find what it changed by. So I know this is 4 minus 3 is 1. Notice this one is not minus 3 anymore. It's 1 plus, because I'm getting bigger, 3. And then I'm getting bigger. So 4 plus 9 equals 13. And 13 plus what gives me 28. I think that's 15. At this point, you want to be really careful of your signs. So if you are struggling with doing this in your head, you should use your calculator. But when you do so, you want to use parentheses. So you want to do the second number minus the first number. And the reason why you want to use parentheses is because, say for instance, here, when you have negative 37 minus negative 317, a lot of students forget that extra negative. But if you see it like this, you know that you got your signs right. Right? So negative 37, negative 317 with an extra minus in between. So just be really careful. Okay, so this is my first difference. It is not constant or the same. If it was, it'd be linear. So now let's continue. From negative 3 to positive 3 is plus 6. 3 to 9 is plus 6. 9 to 15 is plus 6. This is my second difference. If it's always constant, then it is a plus 6. And this makes it a quadratic. Okay. So we can use finite differences and continue further than linear and quadratic. If the first difference is constant, the polynomial is linear. And the degree is 1. If the second difference is constant, then it's quadratic. And the degree is 2. Well, the third difference is cubic with a degree of 3. The fourth difference is something we call quartic, like quarters. The degree is 4. And the last one is quintic with a degree of 5. Okay. Well, we can keep going because it doesn't just stop at 5. But after quintic, it's just like the 6th degree, 7th, 8th, and 9th. So if you have an n, that means any number, then the degree will be that same number. Okay? Excuse me. Now let's do an example. It says to use finite differences to determine the degree of each polynomial function. So I want to find the degree in the table given. Then use polynomial regressions, which is your graphing calculator technology, to find the equation of each polynomial. So there's two parts. You want to determine the degree and find the equation. So let's do this. We are going to just find your degree. Okay, see if you can maybe pause the video here and do this yourself. And then once you've got your degree, unpause your video, but try it yourself versus copying mine. Okay, if you did this correctly, you should see a pattern. And our degree is 3 because it's our third difference. Okay. So now we need to find the equation using polynomial regressions. Okay, so before we begin, this was a while ago, so you might need to write these steps down again. We are going to find and put our numbers in here. Okay, So the first thing you need to do to enter your numbers is you're going to hit stat. I'm going to edit. Let's just put this, just write this down first. Okay. So let's hit stat together. It's right here under delete. You're going to hit enter for edit. And you might have some numbers in here, you might not. But what you want to do is have your x's be L1s. Oh, sorry. So you're going to enter L1 with x's, and L2 is going to be y's. Okay. If you do not have an L1 or L2, you're going to just clear your memory, and just like you do before a test, and that should bring everything back. Okay, if you have numbers here, you want to clear, not delete. So you're going to clear and then go down. And that should take care of it. I'll do it again. Clear, go down. Okay? So now you're going to put in all your numbers. 1, enter, 2, enter, 3, 4, 5, 6, 7. Make sure you hit enter on the last one. Okay? And then you're going to enter 1, 4, 10. Put the numbers in. I strongly suggest that you follow along with this just so that you can see what I'm doing and really make sure that you have the muscle memory in order to do these problems. Let me move this and see if I can get rid of that glare on my paper, sorry. Okay, so we've entered everything. Now we're ready for it to pop out the equation. So get equation. Now what you're going to do is you're going to hit stat again. And this time, instead of edit, you're going to make it do some work, which means you're going to calc. Okay, let's write this a little more. So we're going to hit stat. You have to go sideways. So you're going to do the right arrow and then calc. For calc, you're not going to hit enter. You have to scroll down to the correct function. And this is why you have to find your cubic quartic, right? Find your difference. So this one we know is cubic. You're going to hit enter, and you're going to just hit enter again. Some of you guys have calculators where you have to enter a few times or it'll say calculate. So go down to calculate and hit enter. Now I have this crazy equation. If I don't specify what to round to, you can round to whatever you want as long as it's not a whole number. So I'm going to plug in my A, which is 0.167 x cubed plus 0.5 x squared plus 0.333, I'll be consistent, x, and then plus 0, but I don't need to write that. Okay. I also have something extra on my calculator, and that's r squared equal to 1. Now, that r squared equal to 1 tells me that I am 100% perfect. So watch what happens if I accidentally do a quadratic regression instead. So if I go stat calc, go down to quadratic. And if anything, these numbers look better than the cubic, but do you guys see here it says 0.998? That means it's only 99.8% accurate. It's not 100%. And so this is less accurate than your cubic. And that makes sense because quadratic and cubic, if I'm looking at just the positive side, those dots, like that shape could be quadratic or cubic. And so there's no way for us to know, but the calculator can figure out if it's actually on a quadratic equation or a cubic equation. Okay. So how do you get your r squared onto your calculator? Because when I clear my memory, second memory, and I go to reset on the day of the test, and I clear all memory, everything's going to be gone. Okay, and so what happens now is if I, like including my list. Okay, so let me put this in because I do want to show you guys what happens when forward. Okay, so now if I go second calc cubic, you guys don't have your r squared anymore. So here's how you get r squared. This is called our correlation coefficient. We want it to equal to 1. You are going to hit second 0. And above the 0, you'll see the word catalog. Okay, so, ready? Second 0. And this catalog is a list of every possible operation you can do. We're going to go all the way down to diagnostic. On. So let's just scroll down. There, diagnostic on. Now, just because you hit enter one time doesn't mean it's has anything done. You're going to scroll down and then you're going to hit enter. This is really important. You're going to hit enter and you need to see the word done. Okay. Now, if I second enter and second enter, so cubic, then I can see that I have my r squared equal to 1. Okay. I do want you guys right now to practice all of this. So clear your memory, second plus, reset your whole calculator, and then see if you can run through, enter the numbers here, for example, 2, get an equation, get an r squared. You also have to do all this and see if you get the right number. Okay. So see if you can do all of that and get to the final step and prove that your answer is correct. Pause your video here. I will show you the answer key, but it's not about getting the answer. It's can you get the answer correctly and go through the whole process correctly. Okay. So hopefully you plugged your numbers in, but if you messed up, here are the numbers that you should get. You'll notice that these are whole numbers this time. If you notice something under stat calc, you'll notice that it doesn't go past quartic. So that is a signal on a test if you end up past the 4th difference and you haven't gotten a constant number yet or the same number, something went wrong because you cannot do more than a quartic on this graphing calculator. Okay? Come into class with more questions if you have them, and I'll see you guys later.